right, so today we are going to be solving one-step equations. But first, before we start solving anything, we need to learn a little bit about operations, specifically inverse operations. So what is an inverse operation? Inverse operations are operations that undo each other. So they kind of balance each other out. So what would undo addition? Would be subtraction. What would undo multiplication? Would be division. And undoing a square, so for example, 3 squared, undoing that would be something we just talked about last unit, would be our square root. Okay, so now we know some inverse operations and we know what they are. We're going to state a couple of examples. So what is the inverse operation of adding 23? Well, that would be subtracting 23. Okay, good. How about if we were subtracting 18? What would be our inverse operation? Would be adding 18. Number 3, if we were to multiply by a negative 15, the inverse operation of multiplication we said is division. And we're going to divide by the exact same number, negative 15. That negative does have to come along for the ride. Multiplying by a negative, to undo, you have to divide by a negative. For number 4, if I were to divide by 8, undoing it would be multiplying by 8. Awesome. So how do we put these inverse operations to work? We want to use those to solve equations. Well, an equation is a mathematical sentence that contains an equal sign. So this is our equation. It's really the focus that we have in algebra, is all about how to solve equations, all different types. The goal of solving an equation, so the whole point of this, is to isolate the variable, which means really getting it alone. I want it all by itself with nothing else stuck to it. But I have to do this using the laws of algebra and not breaking any rules, so I need to maintain the balance of the equation. Maintain the balance of the equation. So to do this, we need to undo whatever was done to the variable using those inverse operations we just talked about. So those inverse operations hold certain properties in math, and it's important to know about those before we keep going forward, because they're really the basis of all of algebra and this balance of the equations business we were just talking about. So the properties of equality, how I know I'm keeping the balance, says, the first one, if I add the same number to both sides of an equation, so for example, if I add c to the equation a equals b on both sides, it won't change the balance. And this is our addition property of equality. An addition property of equality. Similarly, on the next one down, if I were to subtract the same number from both sides of the equation, same number on either side, it won't change the balance of the equation. This is our subtraction property of equality. Next one down, if I were to multiply by the same number on both sides of the equation, like c onto the equation a equals b on both sides, that's our multiplication property. Let's see if I can squeeze this in there. Went a little bit over there, that's okay. Multiplication property of equality means we can multiply by the same number on both sides and it'll still be balanced. And last but not least, if we divide by the same number on both sides of the equation, then we won't change the balance either. And that's our division property. Great. So now we're going to put these properties to some use for us. So we're going to solve an equation. So our first example over here says y plus 3 equals 10, and we have to solve it. So in order to solve, this box in the middle tells us to think to ourselves, where is the variable? What was done to my variable? How can I undo that thing that was done? And then make sure I do it to both sides to keep the balance. So our first example, our variable is the y. That's our first question. That's the variable. What was done to it? Well, it was added by 3, y plus 3. So how do I undo that plus 3? Well, undoing addition, I'm supposed to subtract by the same number, 3. But again, in order to keep the balance, I have to do that on both sides. So I subtract 3 to the 10 as well. Y plus 3 minus 3 is just going to leave our variable y. And 10 minus 3 is going to come out to 7. So there's our answer, y equals 7. But we always want to do a check to make sure we didn't goof up. So we're going to plug the 7 back in using substitution to our equation. So 7 back in for y would mean that we had 7 plus 3 equals 10. And we're hoping that that's a true number statement. 7 plus 3 is in fact 10. 10 equals 10. So check, we're all set. Let's try again. Example number 2. Negative 2 equals x minus 7. So again, our variable is the x. What was done to it is the minus 7. I undo by adding 7, keeping the balance, adding it to both sides. X minus 7 plus 7, those go away, leave us just with our variable. And negative 2 plus 7 is going to leave us with 5. So x equals 5 is our answer. Quick check to make sure we did it right. Negative 2 equals, our x that we got was 5 minus 7. 5 minus 7, small minus big, is in fact a negative 2. So we know we did it right. On to the next page, notes. A couple more examples together. So example number 3 is negative 121 equals negative 11a. Our variable a is being multiplied by negative 11. You know that because there's nothing written in between. So in order to undo that multiplication, we're going to divide by the negative 11. Remember that that negative comes along for the ride. We're showing our division using a fraction bar. And we're going to do it to both sides to maintain that balance. Negative 11 divided by negative 11 is just 1. So that leaves us with our a variable all by itself, isolated. And the other side, negative 121 divided by negative 11. Negative divided by a negative is a positive. 121 divided by 11 is 11. So we end up with a equals 11. Our check, negative 121 equals negative 11, and then times, our variable we found was 11. Negative 11 times 11 is negative 121. So we know we got the right answer. A couple more together. G is our variable, divided by negative 7 equals 7. So right now we're dividing, so to undo, I'm going to multiply on both sides by that negative 7 times negative 7 on both sides to keep the balance. Negative 7 times negative 7, or times the divided by negative 7, excuse me, leaves our G all by itself. And 7 times negative 7 is going to give us negative 49. So our answer came out to negative 49. Quick check. We got negative 49 in the spot for G. Ooh, I wrote G. Let's try that again. See. Negative 49 divided by negative 7. Does that equal 7? A negative divided by a negative is a positive, so that's right. So we get 7 and 7. Check. Awesome. Last one. Or no, we got two more. Two more left. Number 5. This one's pretty tricky. We got a fraction. So we're being multiplied by a fraction. So to undo this, we use what's called the reciprocal, or the flip of that fraction. So we're actually going to multiply by the reciprocal. Multiply by the reciprocal. So 3/4 times 4/3, those cancel each other out, and we're just left with an x. And 27 times 4/3, well, that could be hard to do in our heads maybe, but if you use your calculator, it's like dividing by 3 and multiplying by 4. You should come out to the answer of 36. x equals 36. And our check, 3/4 times 36 would be 3/4 of that number. We're hoping it comes out to 27, which in fact it does. 27 equals 27, so we're all set. All right, now the last but not least, we are going to translate. So adding in what we did at the end of the chapter in the last unit onto what we've been doing today in our notes. We're going to translate this number sentence and then solve it. So 20 more than a number is 92. So we know that this a number is our variable. And whenever we see this more than, we want to do that part at the end. So our number is, x is our variable. 20 more than means we're adding that onto our variable. Is stands for the equal sign. And then 92 is providing our balance. So now we have our equation. And we need to identify the variable and undo what's been done to it. So our variable is x, is what we selected for a number. It's being added by 20, so to undo, we're going to subtract by 20 on both sides in order to keep the balance. 20 minus 20 goes away, so we just have our x isolated on the left side. And 92 minus 20 leaves us with 72 as our answer. Last step, make sure we check. Is 72 plus 20 come out to 92? I believe it does. That would give us the number sentence 92 equals 92, and we are all set. So that is solving one-step equations. Get that extra practice on the bottom, and we'll see you in class next time.